Hi everyone. I came up with another important and useful concept in complex numbers, particularly nth roots of unity. It is most important concept of our JEE joint entrance examination for mains and advance of. Okay, so let's look into the problem. Alpha is a nth root of unity, and Z1 and Z2 are the two complex numbers. Then we need to find the value of this expression. In this expression, if we observe numerator, the numerator is summation of the terms which are of the form z1 plus alpha power p z2 whole power 2, where p is running from 0 to n minus 1. Let's look into that first. What are the specialty of nth roots of unity? So alpha is in nth root of unity. There are the number of roots of n 1 power 1 by n will be n roots, and those roots are 1 alpha alpha square so on alpha power n minus 1. Always n roots of unit will be in gp, and each of that one of the value is e power I into 2 pi by n. Then okay, then alpha square will be this one. So general case you can write it as e power I into 2k pi by n, where k is running from 0 1 2 so on up to n minus 1. So the properties of this nth roots of unity is that because all these roots alpha, alpha squares on alpha power n minus 1 are roots of z power n minus 1 equal to 0. So sum of all these roots will be 0 and alpha power n will be 1. So these are the two most useful points here. Now look into the question here. So we are dealing with an expression in the numerator modulus of z1 plus alpha power p z2 whole power 2. So we know that mod z square can be written as z into z bar. Z bar is the conjugate of z. So same thing if we apply here, modulus of z1 plus alpha power p z2 whole square can be written as z1 plus alpha power p z2 into z1 plus alpha power p z2 whole bar. So conjugate of that one, conjugate of Z1 plus Z2 is Z1 conjugate of Z1 plus conjugate of Z2. We know that. So Z1 bar plus alpha power P whole bar into Z2 bar. Right. Now, if you multiply these two, if you multiply these two, that final result comes out to be modulus of Z1 square plus modulus of Z2 square, and Z1 into Z1 bar is mod Z1 square, Z2 into Z2 bar is mod Z2 square, and you know that alpha P or P into conjugate of that is 1 because they are nth roots of unity. So this is modulus of P whole square, that is 1. So mod Z2 square, and the remaining expression is this one. And if you observe that, if you take LCM, because in the question we need the sigma of this. So if we apply sigma for this, so mod Z1 square common, mod Z2 square is also constant with respect to sigma notation, and the sigma for sum of all roots will be 0. So once the sum of all roots will be 0 and sum of alpha bar p also will be 0 because their conjugates will be another nth roots of unity only. So now if you take a sigma for this expression on both the sides, then it will come so to be n times because of mod z1 square is common constant sigma 1 value is 1 n. So n similarly mod z2 square into sigma 1, that value will also be n. So n times mod z1 square plus mod z2 square, and remaining terms two terms sigma notation, the sigma of that one will be 0. This part will be 0, this part will be 0. So we came up with numerator. The numerator is coming to n times mod z1 square mod z2 square. So that the required expression will be n.